Imagine a world where one wrong step could mean your doom, where the ground beneath your feet might turn to glass with a single crack. Today, we're about to embark on a journey that will take us to the very core of the Earth and uncover the secrets of supervolcanoes. These geological giants are so powerful that their eruptions can literally change the course of human history. And the scariest part is some of them may be hiding in plain sight, waiting to unleash their fury. You won't believe the cataclysmic events that have already unfolded from these colossal craters. From the colossal depths of Yellowstone to the enigmatic Long Valley Caldera, we'll explore the hidden dangers lurking beneath our feet. Are you ready to learn more? If so, keep watching. Yellowstone National Park, a place synonymous with natural wonders, geysers, and untamed beauty. It attracts millions of visitors each year who come to witness its grandeur. But beneath this mesmerizing landscape lies a secret, a supervolcano that could potentially trigger a global catastrophe. It's a sobering thought, but one we must confront as we learn more about this hidden danger. The Yellowstone supervolcano is no ordinary geological formation. Its sheer size and potential for massive eruptions make it a subject of both fascination and fear. Located in the northwest corner of the United States, the volcano spans an area roughly the size of Rhode Island. Over the past 640,000 years, it has had 3 major eruptions. The most recent occurred 63,000 years ago. Just imagine the explosive force unleashed during those events. The 1885 eruption of Krakatoa in Indonesia released about 200 cubic miles of ash and pumice. In comparison, the 1980 eruption of Mount St. Helens in the US released about 12 cubic miles. But the largest known eruption in history, the 1815 eruption of Tambora in Indonesia, released just over 350 cubic miles. Yet even these staggering figures pale in comparison to the immensity of Yellowstone's eruptions. The supervolcano's historical eruptions were estimated to have released over 2,400 cubic miles of material, a truly mind-boggling amount. But why does the Yellowstone supervolcano pose such a significant threat? The answer lies in its potential for catastrophic eruptions. Unlike typical volcanoes, which have a magma chamber that feeds directly into a central vent or multiple secondary vents, the Yellowstone supervolcano has a much more complex structure. Its magma chamber extends for miles beneath the Earth's surface, and instead of a single vent, it has numerous superplumbing vents. This unique feature allows magma to escape in various directions, potentially leading to massive lateral blasts. And when we talk about massive, we mean truly colossal. Unlike typical volcanic eruptions that can be measured in terms of thousands of cubic yards of material, supervolcanic eruptions can discharge over 1,000 cubic miles. To put that into perspective, the entire state of Connecticut would be completely obliterated by just 1% of the material ejected from Yellowstone during one of its major eruptions. As we delve deeper into the science behind supervolcanoes, we encounter a term that may sound like something out of a sci-fi movie: the magma chamber. This is the reservoir of molten rock or magma that lies beneath the Earth's surface, similar to a giant underground lake. However, unlike a typical lake, the magma chamber is not filled with water. It's a seething cauldron of molten rock that can reach temperatures exceeding 2,000 degrees Fahrenheit. Imagine the immense pressure and heat required to create such scorching temperatures. The pressure within the magma chamber can be so intense that it literally pushes the surrounding rocks outward, creating vast calderas. Calderas are essentially large, low-lying areas that form as a result of the pressure release following a volcanic eruption. They serve as a reminder of the incredible forces at play beneath the Earth's surface. Yellowstone's magma chamber is not just any ordinary geological feature, it's a ticking time bomb that could potentially trigger a supervolcanic eruption. The chamber is estimated to be around 43 miles long and 25 miles wide, stretching far beyond the boundaries of Yellowstone National Park. The depth of the magma chamber is equally astounding, extending down nearly 4 miles into the Earth's crust. It's like looking into the fiery heart of our planet. Within this underground magma chamber, the story of Yellowstone's volcanic activity comes to life. Over millions of years, the North American plate has been moving steadily to the northwest at a speed of about 1 inch per year. This movement carries the Yellowstone hotspot, the engine driving the volcano's activity, over an area of weak and malleable rock known as the Yellowstone hotspot. As the plate continues its journey, the hotspot melts the rock below, forming magma that rises to the surface. This continuous process fuels Yellowstone's volcanic system, making it one of the most active geothermal regions on Earth. But what happens when this magma finally reaches the surface? That's where the concept of eruption comes into play. Eruptions are the dramatic moments when the pressure within the magma chamber overcomes the weight of the overlying rock, allowing the molten contents to escape. At Yellowstone, eruptions can occur through the park's famous geysers and hot springs, or through more explosive means. During an eruption, the magma violently bursts from the Earth's surface, accompanied by the release of gases and other substances. The force of the eruption can be so powerful that it creates massive explosions, sending ash and debris high into the atmosphere. And when these eruptions occur on a grand scale, they earn the title of super eruptions. Super eruptions are incredibly rare events that occur once every several 100,000 years. They are so powerful that they eject more than 1,000 cubic miles of material during a single event. Yellowstone has experienced 3 such eruptions in its history, each leaving behind a caldera as evidence of its colossal power. But what if another super eruption were to occur tomorrow? How would it impact our world? The consequences of a super eruption at Yellowstone would be nothing short of catastrophic. Ash and debris would blanket vast areas of the surrounding states, affecting air quality and disrupting daily life. Pyroclastic flows, avalanches of hot gas and solid material would race down the slopes of the volcano, incinerating everything in their path. Even distant parts of North America would feel the impact, as the eruption column punched through the atmosphere, blocking sunlight and disrupting weather patterns. Global temperatures would plummet, leading to an ice age that could last for years. Yet despite the potential devastation, there is a strange allure to these supervolcanoes. They hold a morbid fascination for humans who have always been drawn to the extremes of nature. For centuries, people have explored the dangerous slopes of volcanoes, eager to witness their awesome power firsthand. But it's not just the destructive side of these geological giants that captures our attention. Volcanoes also have a remarkable ability to create new life. The fertile soils around them are rich in minerals and volcanic ash, providing the perfect conditions for agriculture. Human settlements have flourished in these areas, allowing civilizations to thrive. Ancient cultures often revered volcanoes as sacred places, believing them to be the home of gods or supernatural beings. Today, we continue to be captivated by their enigmatic presence. Millions of people visit volcanic regions each year, marveling at their beauty while acknowledging the potential danger. Long Valley Caldera, a name that echoes with the power of nature's fury. This vast volcanic depression is located in the eastern Sierra Nevada mountains in California. It holds within its depths a history of cataclysmic eruptions that have shaped the landscape and fascinated scientists for centuries. Measuring approximately 7 by 12 miles, the Long Valley Caldera stands as a testament to the explosive events that have occurred here in the past. But what makes this caldera so intriguing is the mystery surrounding its formation. Unlike other calderas that have formed from single eruptions, the Long Valley Caldera is the result of multiple overlapping events. The first major eruption occurred around 760,000 years ago, creating a caldera that was later filled by a thick layer of ash. Another significant eruption took place approximately 380,000 years ago, followed by smaller eruptions over the next 150,000 years. These eruptions contributed to the formation of the Bishop Tuff, a thick layer of ash that covers much of the eastern Sierra Nevada. But the Long Valley Caldera doesn't end there. A younger supereruption occurred around 6,000 years ago, forming the most recent Bishop Tuff. This eruption produced voluminous ignimbrite flows that spread across the Owens Valley, and covered an area of over 2,300 square miles. The force of the explosion was so great that it created a pumice raft in what is now Mono Lake. This pumice raft, along with the ignimbrite flows, serves as a reminder of the immense power that lies dormant beneath the surface. But how do scientists unravel the secrets of these ancient eruptions? The answer lies in the scientific techniques used to explore the depths of the Long Valley caldera. One such technique is gravity exploration, which involves measuring variations in the Earth's gravitational field. By analyzing these variations, scientists can identify differences in the density and composition of the subsurface materials. Gravity exploration helps scientists understand the structure of the Long Valley caldera, providing insights into the sequence of eruptions and the properties of the erupted materials. Now let's dive deeper into the fascinating world of volcanic activity. We'll explore another supervolcano that has captured the attention of scientists and locals alike. Get ready to learn more. Mount Mazama, a name that resonates with the power and mystery of volcanic landscapes. This massive stratovolcano stands as a silent giant in the heart of what is now Crater Lake National Park in Oregon. But unlike many active volcanoes, Mount Mazama is now just a distant memory. It's a dormant volcano, meaning it is unlikely to erupt again, but it's not quite extinct. The last time Mount Mazama rumbled to life was around 7,700 years ago, when it experienced a cataclysmic eruption that left an indelible mark on the region. Imagine a scene straight out of a prehistoric epic. Molten lava spewed from the summit of Mount Mazama, cascading down its slopes and reshaping the landscape. The eruption was so violent that it emptied the magma chamber beneath the volcano, causing the upper portion to collapse. This collapse created a massive crater, which over time filled with rainwater, snow and ice, forming the now famous Crater Lake. Today, visitors to Crater Lake National Park can stand at the rim of the caldera and look down into the depths of this mesmerizing blue lake. The lake's vibrant color is due to its extreme depth and the way light interacts with the water. But the story of Mount Mazama doesn't end with its last eruption. Scientists continue to monitor the volcano's activity, searching for signs of renewed life. The U.S. Geological Survey maintains a seismograph network in the area to detect any seismic activity that may indicate magma movement beneath the surface. Additionally, scientists monitor the gases that emanate from the lake and surrounding areas, as changes in gas emissions could signal increased volcanic activity. Now let's shift our focus to another intriguing aspect of these supervolcanoes, the superplumbing. No, it's not a new plumbing system for superhumans. It's a fascinating geological feature that plays a crucial role in volcanic activity. Superplumbing refers to the interconnected network of vents, conduits and chambers that allow magma to travel from deep within the Earth's mantle to the surface. It's like an underground highway system for molten rock. These superplumbing systems are particularly extensive and efficient, allowing for the rapid transport of magma. The sheer scale of the plumbing networks associated with supervolcanoes is truly awe-inspiring. They stretch for miles beneath the Earth's surface, connecting magma sources deep in the mantle to eruption sites. Understanding these superplumbing systems is essential for comprehending the behavior of supervolcanoes. By studying how magma moves through these networks, scientists can gain insights into the frequency, intensity, and potential hazards of future eruptions. In the ongoing quest to unravel the mysteries of supervolcanoes, scientists are constantly pushing the boundaries of knowledge. They use advanced technologies to peer deep into the Earth's crust, seeking to understand the inner workings of these colossal geological formations. By exploring the superplumbing systems, eruption history, and potential hazards of supervolcanoes, scientists aim to provide valuable insights that can help mitigate the risks associated with these natural wonders. Their findings not only expand our understanding of the Earth's dynamic processes, but also ensure the safety and preparedness of communities living in volcanic regions.